Acme Manufacturing, we not only make anvils, but we make rocket skates. I'm sure if you've watched enough Roadrunner cartoons, you've seen Wile E. Coyote get his package from Acme Manufacturing, and it has his rocket skates. He puts those rocket skates on in an effort to go fast enough to catch the Roadrunner. It never seems to work out for him. But we sell those rocket skates. We make them here and sell them. And one day of production, we made 80 pairs of rocket skates at a production cost of $11,000. Another day, we made 57 pairs of rocket skates at a cost of $8,700. We're going to sell those rocket skates at $250 a pair. So the question is, how many pairs of rocket skates do we have to make every day in order to break even? Well, in the last video, we saw what you have to figure out, to calculate the break-even point. You have to have your cost function and your revenue function. So from this information, we have to construct those two functions. Well, it's relatively easy to construct the revenue function when you know how much you're selling the item for. We're selling them for $250 a pair, so our revenue function would be 250x, where x represents the number of pairs of rocket skates that we're going to make and sell. That wasn't too tough to construct that revenue function. But it's a little more work here to find our cost function. Remember, our cost function is a linear function, so it's going to have the form mx plus b. So we have to find the slope and the y-intercept. We have to find the m value, the b value. Well, slope is change of y, or the change of the cost, over change of x. X is the pairs of rocket skates we're going to make. So we have the information here that we can use. We have costs and we have pairs of skates. We've got a change of y and a change of x. Y is cost. Remember, C of x is like having y. Change of cost over change of pairs, that's the cost per pair, that's our slope. Or in the business vernacular, that's our unit cost. So if we use those figures, 11,000 minus 8,700 gives us a change of cost, and we're finding our m value, gives us a change of cost of 2,300. 80 and 57, the difference there is 23, so that's a value of 100. So that's $100 per pair. That's our m value. That's our slope. So my cost function now looks like this. C of x equals 100 x plus b. My slope, my change of y, which is cost, over change of x, which is pairs, came out to $100 per pair. And now I just have to find my b value. So I can take one of these cost figures, like the 11,000, take the corresponding number of pairs, plug those in for x and y, and I can now solve this equation for b. 100 times 80 is 8,000. Subtracting 8,000 from both sides, I get b equals 3,000. So now I know my b value in the business vernacular, my fixed costs, are $3,000. So when I am making my rocket skates, they cost me $100 a pair, and I have fixed costs of $3,000. So these costs have to be offset by this revenue. And I want to figure out how many pairs do I have to make and sell so that the revenue, 250x, equals the cost, 100x plus 3,000. 1,000. I have to find the right number of rocket skates to make so that the revenue, $250 times every pair, covers the cost, $100 times every pair plus $3,000 fixed costs. And I have a nice linear equation in one variable that I can solve for x. Subtract 100 from both sides, I get 150x equals 3,000. So x would equal 20, wouldn't it? Isn't 3,000 divided by 150 20? So I have to make 200 pairs of rocket skates to break even. My break-even point is 20 pairs of rocket skates. Once I've made that 21st pair, I'm going to start making some profit. Because profit is your revenue minus your cost, which we want to look at in our next video.